Lesson 1-4, the distributive property. Okay, we're going to use the distributive property to evaluate expressions today, and we're going to use it to simplify expressions. Remember, evaluate means to find the value. Simplify, we'll find out, means to get all the like terms together. Okay, and that brings us to new vocabulary. We'll be actually not new, but probably review vocabulary. We're going to look at like terms. We're going to look at simplest form, and we're going to look at coefficient. So go ahead and look those up, and I'll be back with you in just a second. Pause the video, and I'll see you guys in a second. All right, so distributive property. The key concept of distributive property is if you have A times B plus C in parentheses, then that is the same as multiplying A by everything inside the parentheses. So A parentheses B plus C and parentheses is the same as A times B and A times C. Whatever is outside the parenthesis multiplies every single term inside the parentheses. In numbers, that looks like 4 parentheses 5 plus 7 and parentheses is the same as 4 times 5 plus 4 times 7. 4 times 5 is 20, 4 times 7 is 28, so our total would be 48 on this. If you have a subtraction sign, it still works the same way. You're going to do 3 times 6 and 3 times negative 2, or times 2. You can set it up as 3 times 6 minus 3 times 2, or you can say 3 times 6 plus negative 3 times 2. You can set it up either way, right? Because a minus sign is the same as plus a negative. And remember, the opposite is also true. Because of the symmetric property, which we learned about yesterday, if one thing is true, then if you put it in reverse order, the same thing is true. So if we have A times B plus, that should be, scratch that. If you have A times B plus A times C, that is the same as A times B plus C. All right? Before we had said if you had A parentheses B plus C, that's the same as AB plus AC. Now we're saying AB plus AC is the same as A times B plus C. Okay, symmetric property example. All right, let's look at a couple and see how we do with these. Here we have 7 parentheses 3W minus 5. We're going to rewrite these using the distributive property, and then we will simplify. Okay, so we're going to multiply what's outside by everything inside. So that'll be 7 times 3W, right, minus 7 times 5. 7 times 3W is 21W minus 7 times 5 is 35. And that expression is simplified because 21W and 35 are not like terms, so we can't combine them. We can't add 35 to 21Ws. Remember, 21Ws means we have exactly that many W's, 21 of them, and on and on and on and on, okay? 35 doesn't have any W's. It's just plain old 35. So you cannot add it or subtract it from something that has W's attached to it. Okay, here we have 6V squared plus V minus 3 times 4. Now this time you'll notice the number is at the back of the parentheses. And you'll notice that we have 3 terms, 6V squared, V, and negative 3 inside of parentheses. Same rule still applies. We're going to multiply the 4 by each one of these terms. Okay, so let's get started. 4 times 6V squared. 4 times 6V squared plus 4 times the second term, which is V squared, which is just plain V, minus 4 times the 3. So 4 times 6v squared is 24v squared, plus 4 times v will be just plain 4v, minus 4 times 3 is 12. And that is simplified. This has v squareds with it, this has plain v's with it, and this has no v's with it. So none of those can be added together. We'll talk about that more in just a minute, simplifying terms. Okay, I'd like you guys, your practice is going to be embedded in your lesson. Instead of everything being at the end, you're going to have a few problems as we go through the lesson. So let's try these. Well, these will be just simplifying the, just using the distributive property to do these problems. I'm actually going to do 3C with you, and then you'll only have to do 3A, 3B, and 3D. I want to talk about this negative term outside. Remember, you're going to be multiplying by your parentheses by a negative number, by -3, right? Okay, so -3 times 2, and that -3 times that guy. So -3 times 2 minus, or -3 times 5q. All right? So -3 is times the 2, and it's also times the 5q. So that'll be -6, and -3 times 5q is -15q. Now look what happens here. -6, I have a minus situation. What does that change to? Plus plus. So -6 plus 15q. You're going to get something like that over here in 3D, so I thought I'd show you how to do one of them. And good luck with those. Pause the video, complete them now, and then go on and take your notes for the next part. All right. Let's review. A term is a number. You've already looked this up. Oh, no, we didn't look up a term. A term, remember, can be the number, it can be the variable, or it can be a product or a quotient of numbers and variables. So let's think of some examples. So if we have 3x plus 1 plus 1 over x plus 7, okay? So this right here is a term. It's just a plain number. 1 over x is the quotient of a term of a number and a variable, and here's a product of a number and a variable. So we have 3 different terms as they're listed right now. All right, like terms are terms that contain the same variables. The same variables. Okay, and what we want to do is they also have to have the same power. Same power. So same variables, and they have to have the same power. So here in our example right here, we have 3 terms, 5x squared, 2x, and -4. They're 3 separate terms. These 2 guys don't have the same power, so they're separate terms. Over here in this example, 6a squared and a squared have the same powers. So they are what we call like terms. A squared and a are unlike terms. Remember that. And when you simplify an expression or put it in simplest form, you want no like terms or parentheses. So if we look at our problem up there, 6a squared plus a squared plus 2a, that is not in simplest form because we have 2 terms, 6a squared and a squared, that have same variables and same powers. So we can combine these 2. So 6a squared plus a squared, remember, there's that 1 in front of a that we don't normally write. So we have 7a squared total plus 2a. And now that expression is in simplest form. Let's try combining some like terms. we have 17u plus 25u. And you'll remember that if they have the same variable, you can add them together. So if we think in simple terms like 2u plus 4u, right? Here's 2u's here and here's 4u's here. How many u's do I have altogether? Yeah, I have 6 of those little u guys, all right? Same approach here. We have 17u plus 25u. We'll add the coefficients together. 17 plus 25 is 42 u's. Okay, 6t squared plus 3t minus t. Oh, well, I'm going to go ahead and put a 1 right in front of there because I know it's there. It's just hiding, just to remind myself. Okay, so we have like terms right here. So I have 6t squared plus 3t minus 1t will be 2t. Simplest form right here. Okay, your turn again. Go ahead and pause the video. Do these 4 practice problems. Simplify each expression. Notice if it's not possible, write that it's already simplified. Okay? Good luck. Okay, now we're going to write and simplify expressions. We're going to take the verbal, the word form of the problem and change it into a number form of the problem. So you can see here we have the problem twice the difference of 3x and y increased by 5 times the sum of x and 2y. Let's read that again. We have twice the difference of 3x and y increased by 5 times the sum of x and 2y. All right, I sort of see something like this. Twice the difference of 3x and y. That's going to be one of my things. Increase, that's going to be plus. Increase by 5, it says. Let's hold on here a second. We have increased by 5 times the sum of, so increased is plus, by 5 times the sum of x and 2y. So let's take this first one. Twice the difference of 3x and y. So twice the difference of 3x and y. How do we write 3x and y? And the difference of that. 3x, how do we write this? The difference of 3x and y. That would be 3x minus y. And twice that would be 2 times that. 2 times 3x minus y. Plus 5 times the sum of x and 2y. So the sum of x and 2y we would write as x plus 2y. That's the sum of x and 2y, isn't it? And 5 times that. So there's our expression, 2 times 3x minus y plus 5 times x plus 2y. All right? Now they also want us to simplify that and put our like terms together. We're going to have to extend our page for this one. This is going to be a little bit of a long problem, but let's go ahead and do it now. So now our next step is to distribute 2 times 3x, 2 times y. All right? So 2 times 3x minus 2 times y plus 5 times x and 5 times 2y. 5 times x plus 5 times 2y. All right, 2 times 3x is 6x. Negative 2 times y will be negative 2y. Plus 5 times x is 5x. Plus 5 times 2y is 10y. All right, if you wanted to know, I was doing the substitution property right there, wasn't I? Here I use the distributive property. Okay, I'm now going to use the commutative property. I'm going to commute my terms around. I'm going to put my like terms together. So I'm going to put like terms together. All right, what are my like terms? Here are my like terms. 5x, the 6x and the 5x are alike. And the negative 2y and the 10y are also alike. So I'm going to put those beside each other. So I'm going to say 6x plus 5x, put those two guys together, plus negative 2y plus 10y. I'm going to put those guys together. Now I'm probably going to do a little associative grouping too, aren't I? Okay, so 6x and 5x is 11x. This will be substitution. And plus negative 2y plus 10y is 8y. Now these two terms are different. They're not like terms, so I cannot add them together. And there's the solution to that problem. A little bit long, but very logical step-by-step approach. Okay, your turn. Try this expression. 5 times the difference of a squared and r, of 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. Let's read that together again. 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. Okay, so write the algebraic expression for the verbal expression and then simplify and indicate the properties that you use to do that. All right, good luck with that one. You can pause your video, work through it, get back with me in just a second. Okay, one last thing I want to talk about is the term coefficient. The coefficient is the number part of the term. When I ask you what the coefficient is of 4x, I'm asking you what is the number part of the term. What's the 4? So here's an example. What is the coefficient in 6ab? It is 6. All right, a and b are the variables. 6 is the coefficient. The whole thing is called a term. That's the coefficient. And these two guys are the variables. All right? Okay, let's look at x over 2. Let's look at this one. X to the power of 2 over 3. What is my coefficient here? Think about this. What is the number that's in front of the x? There's a 1 in front of the x, isn't there? So let me ask you a question. What's the variable? The variable is x, or x squared actually. What's the coefficient? 1 over 3. The 1 over the 3. Tricky, huh? Just wanted to point that one out. You might have something like that in your homework tomorrow. I think that might be it. That is pretty much our last slide. This last slide right here is just a summary of the properties that we've used today. Commutative property, so where you're moving them from one place to the other. A plus B, we moved it to B over here and A over there. Associative property, where we changed the grouping. We changed where the parentheses are. Identity, a plus 0 equals 0, and a times 1 is 1, so that's the addition identity and the multiplicative identity. The property is 0, is a times 0 is 0, and distributive property, what we talked about today, and substitution we've been using all through this lesson. All right, guys, that's it. A little bit shorter. You should be happy with that. Have a great weekend. And I will see you guys on Monday. And just to remind you, we'll learn one dash. Actually, this is the last one we'll learn before our quiz. It'll be Tuesday for C hour and Wednesday for D hour. Have a good weekend.